Okay, and hello to AWS series part 3. Today we're going to talk about EC2 instances, which is one of the most fundamental topics of AWS cloud. Also, it's one of the most important topics in every exam, especially if you're taking solutions architect, associate exams, any kind of exam you want to take. This EC2 is a very fundamental part. It's also one of the first services for AWS. SKS, of course, was the first service, but also EC2 is one of the first services as well. I think the first service is SQS in 2006, and EC2 is 2008. So it's one of the really fundamental services right here. Of course, EC2 is, or it's about Elastic Compute Cloud. So basically a laptop, and we're gonna talk about it in these slides. So we're gonna give a brief introduction. We're gonna understand, of course, we had a full week of Linux or 2 weeks of Linux, so we've understood the term of virtual machine. So I think the cloud journey is gonna be easier. So we're gonna give a brief introduction. We're gonna talk about the instance types. I have put a table to summarize everything up. We're gonna talk about security and networking. We're gonna talk about security groups. We're gonna talk a little about VPCs and subnets. I don't want to go really deep into VPC because we have a whole day coming to VPC. We're gonna talk about IP addresses and Elastic IPs. Also, we have give a brief networking introduction, so I'm not gonna also dig deep or not gonna have a deep dive in IP addresses, but we're gonna have a deep dive on Elastic IPs. Also, storage options. I have 2 days coming for those, so I'll leave them to these days. I'm gonna give a brief discussion about storage options. So we have 4 storage options we're gonna talk about, but um, not like a lot. So we're gonna just like give them a brief so you can know them. We're also gonna have monitoring and management. We're gonna talk about pricing and cost management, and we're gonna give best practices. Okay, so for the best practices part, I have included in every slide for every topic. I have included the best practices I think that are more suitable to use this service. So let's begin. So in the introduction slide, we're going to talk about what is the EC2 instance, what are the configurations that we are going to use, what is user data, and what is AMI, so Amazon Machine Image. We're going to talk about this. So first thing, an introduction about EC2. We said it's a web service. Of course, every cloud service is a web service because it's accessed via the portal or via the browser, and it provides a resizable compute capacity in the cloud. So as we know, resizable means elasticity, means scalability. We're going to talk about these um, in the upcoming slides. So it is designed to make a web scale cloud compute. I don't want to like read out of the slides. We just need to understand that basically EC2 or Elastic Cloud Compute is a virtual machine with many different sizes and many different options that you can choose from. So I don't want to read off the slides. Okay, so basically, what are the benefits of EC2? So we have more than 4 benefits, but I have put or collaborated together one of the most benefits that we can use from using EC2. So the first thing is scalability, and we have talked about scalability. We're going to understand the topic of scalability. Is it vertical or horizontal scalability? And we're going to talk about it in the upcoming slides. So it's either you add or remove instances or you resize them based on demand. Okay, so flexibility, also you have different ranges of types, different range of use cases that you can use, and we're gonna see that in the console when we come to it. Also, we're gonna, one of the benefits or the third benefit of EC2 is cost. So you only pay for what you use. And this is one of the like, why are you using cloud? Because it's I think much cheaper than using it on premise. So you only pay for the resources you use. And also security, we're gonna see how we have this thing called security or security. Oh, I forgot. Security group, yeah, security group and network access control lists. We're gonna like dig deep really into these topics, so we're gonna understand. So I think today's session is gonna be a little bit long. I'm gonna try and keep it brief and short as much as possible. Okay, so first thing we're gonna talk about, as we said here, which is the number one benefit, it's scalability. So we have vertical scaling and horizontal scaling. Okay, so we have two types of scaling. It's either vertical or horizontal. يا إما بالطول أو بالعرض. تمام. فخلينا أول إشي ناخد اللي هو بالطول. So let's imagine, okay, I have this band right here. Let me show it to you guys. So I have this band right here, as you can see. So let me stop the share and you're gonna see. So I have this virtual machine right here in my hands. And a lot of customers came in and I need to serve them. And this band cannot serve these type of customers. So I need to resize it and make it serve more customers. So this is a vertical scaling. So it's from like 2-3 centimeters until like 6-7 centimeters. It's in centimeters. Let's do it in CPU and memory wise. The bad thing about vertical scaling is you need to shut down and then resize your virtual machine, then reinitiate it or turn it on again. So there is a downside or a bad thing about it that you have to turn off the instance before resizing it, then turning it back on. So there is a downtime. This is called a downtime for this process. So, and it's also a manual process. I really don't recommend it. As a solutions architect, we recommend, or AWS actually recommends using the horizontal scaling. It's much cheaper, it's more automated, and it's more flexible, and it's more cost efficient. And there is no downtime. So we're gonna talk about it even more. So let me get a few bands more. I have like a lot. So also about the vertical scaling, we said we're gonna resize the virtual machine. Either it's from CPU to memory. We have a lot of options to choose from, and it is done manually. So not the best decision. So what is the horizontal scaling? So let's go back at the window and let's see the horizontal scaling. Yes, scaling. So basically, horizontal scaling is different than vertical scaling. Vertical scaling, you're only working on one virtual machine or multiple, but typically it's one virtual machine and you're resizing its CPU, its RAM, its capacity, its resources, and there's a downtime for this process. But horizontal scaling is adding or removing instances based on demand. So let's see. I have a few uh, I have few bands right here that I want to make it a little bit bigger so you can see them. So let's say I have this virtual machine, and this virtual machine is not enough to serve 500 customers, so we begin adding more instances to it. And as you can see, we haven't turned this one off. It's still working, but we have added more copies of this virtual machine. So as you can see, this is like vertical or sorry, horizontal scaling. So you just add more instances based on demand. So why do we need this? Why are we talking about scalability? Why are we talking about this concept in particular? I'm going to tell you why. So let's have a graph. Let me draw one. Let me draw one. So I have got my board ready, and let me uh, draw how typically they do the usage. Okay, so let me try and use the pen. Okay, so let's say this is our graph, and this is like January. Oh, sorry. And this is March. And this is, let's say maybe July. because we're in July right now. Okay, so let me take this color and let's begin. So basically, when we're on our let's say when we have our own data center, it's either we take this and we get resources to serve this much, or we get the absolute. So either we take this one or this one. So I think this was called the median. You take the median for this and you buy resources. So this is on premise. So I can say, why is it small? It's very small. Okay. It's on prem. Let me make it a little bit bigger because I wear glasses for now. So here you can see either you take the median for the usage or you take the full capacity, and this is on-prem. Both sides, either you're gonna not serve these guys right here, so this is not served, and you're gonna have a very big downtime, sorry. You're gonna have a very big downtime, or you're gonna like pay a lot here. So we have like this thing called in Arabic يطخ يكسر مخه. No solution in the middle. But what does the cloud give us? Cloud give us the opportunity to use resources based on demand. So you're gonna only pay for this. You're not gonna pay for the median. You're not gonna pay for the full capacity right here. You're only gonna pay for, let's say, let me go back and remove this line right here. So you're only gonna pay for as much as your customers are needing. So this is one of the benefits of horizontal scaling. It gives you the ability to have this diagram right here. So other removing instances based on demand, they're the same copy or maybe different copies. I'm gonna talk about it even more. So you can like change the instance. You can have something called the spots instance, and we're gonna talk about it even more. Okay. So the next topic we're gonna talk about is high availability. It's also one of the upcoming services we're gonna talk about, which is the ELB or Elastic Load Balancer, which serves us the high availability we need. But we can do it without a load balancer. A load balancer is a solutions architect thing. So of course we have zone A and zone B. So let's say if zone A, let me also remove all these. Okay. Ah, really good eraser. I like it. Can I remove you? No. So basically I have to remove you manually. Okay. So let's say, where is my pen? Yeah, here it is. So let's say we have high availability. Let's say we have 3 zones. So 1, 2, and 3. This is zone A, this is zone B, and this is zone C. Let's say we have a virtual machine right here and a virtual machine right here. And a virtual machine right here. Why not? Because we already have done like 3. So let's say that we only have zone A. So let's begin with zone A. And we only have a single point of failure. Do you remember this concept? A single point of failure is we having one server that serves all the customers and not having a backup. So if we only upload it on zone A and not B and C, we have a single point of failure. Okay, cloud is durable, cloud is resistant, cloud can have availability, but if we upload it on a one zone, we can, like natural disasters, who can guess? Power outage. No one can guess this type of stuff happening. So if a natural disaster occurs and zone A is out of service, now your whole system is down. So you're having downtime. So the best thing to do that is going to upload the same virtual machine into different zones. So if zone A shuts down, you go directly to B. And if zone B shutdowns, it's going to go directly to C. So as much as you distribute your EC2 instances on different zones, you're going to have high availability. And that's what we need. That's why we have zone A, we have 2, and zone B, we have 2. It's not zone B, it's zone B. Maybe a zombie apocalypse. That's why we need okay, that's a good meme actually. I'm gonna do this. Let me insert a zombie. I don't want it to be scary, so zombie. Oh sorry, zombie. We have no zombies right here. Why? That's weird. Okay. So let's just imagine this zombie whenever we're thinking of high availability and it's shifting from down A to, sorry, from zone A to zone B. Zone B. That's funny. I can't even forget that. Okay. Okay, so we talked about vertical scaling and horizontal scaling. We have talked about that. Looks funny. Okay, and we're gonna go now to configuration. And we're gonna see here, this is the terminal configuration. So if we went to our console and we have entered AWS configure, let it wait. It's connecting. Just give it a moment. We have said we have the opportunity to download the terminal and use AWS on our terminal. So let's say AWS configure access ID. Do I have access ID? None. I don't have any kind of ID. Okay. I think those are the configuration. Let's say AWS EC2 configure. What's gonna give us? Okay. So it have gave us a lot of stuff. So let's check it out. We have accept, we have a lot of stuff. So create image, we have tags, subnet, a lot of things. Okay. So as we can see here, we have learned to use Linux. So basically, we're gonna say AWS EC2 run instance, and we're gonna give those options. Do you remember the dash option? So when we were like listing stuff, we were putting like dash LA to give the long format. So these are the options. So we have the image ID AMI. We're gonna talk about AMI and images, and we want only one instance, and its type is going to be T2 micro. We're going to talk about it. So this is general compute. Key name, this is optional. Also security group and subnet ID. So this is, some of them are optional, like the key name. And let's see what is EC2 AMI. So EC2 AMI is basically, I don't like reading off the slides. I think I have put it here. So it's basically an image of a virtual machine. It captures the operating system and the machine's configuration. So this is used to automate the launch of EC2 instance. Like we can have EC2 instance with specific software installed. Like maybe let's say we have learned how to install Apache and MySQL Server and to put a PHP script in them. So I want this server to have copies. So we use an image to copy the system. This is used in horizontal scaling. This is used in load balancing. So if we went to EC2, we can have a system that is specific for here. If we went to EC2 console, we're going to have images, we have AMI catalog, and we have AMI. Of course, there's three types of AMI. So, okay, so there's three types of AMI I'm going to talk about. We have a public AMI, we have a private one, and we have a marketplace one. So public is provided by AWS, private is created by us, and it's not shared by default, and marketplace is on the, like, the companies are selling it. So let's go to the AMI. As you can see here, we have like multiple AMIs. There's owned by me, there is private images, public images. So you can see here, if we shift it to public images, we have Debian, we have Ubuntu, we have Red Hat Enterprise Linux, we have Windows. So we have a lot of stuff. Even when we want to launch an instance, so if we said private, I don't think I have any kind of private images. I don't, yeah. And there is disabled images and owned by me. So if we want to build one, we can create an instance or use this EC2 image builder. And I don't want to use the builder. So we can create an instance and we can turn off this instance, then capture an image, then creating this image. So let's launch an instance. Let's call it my web server. and I want Amazon Linux. So this is a quick start. This is AMI, as you can see here. Um, we have the quick start, which is the public images. Here you can see that we have the marketplace, we have community images. So here you can see is verified community AMIs. So here you can see that we have Microsoft, Ubuntu, Debian, like a lot of stuff. And I think these are for sale, so those are not free. Yeah, I don't think these are free. So here we have also marketplace AMI. So I think if we like entered, let me see, something we know. So yeah, Fortnite. So this is certificates, Cisco, as you can see here. So there's a lot of ready to use and to buy operating systems. So let's go back. I don't want to like go very far away. So I just want, let me go back, launch an instance again. Let's call it my web server. Okay, so I don't want to launch it right now. I want to wait after the user data, which is here in advanced detail. So let's talk about user data, which is here the last thing. And I'm gonna tell you about user data. Okay, so basically user data is, I don't want to read off slides. So it basically is, if you want to download like Apache when you're turning on an instance, it does that for you using a bash script. And we have learned about bash scripting, which is the shebang line at the first. Here you can see, so here's bin bash script. So this is the shebang line. It's gonna update, it's gonna install HTTPD, which is Apache. This is Linux, that's why it's yum, not APT. If it was Ubuntu, I would like say apt or sudo apt install -y Apache 2. So just remember that this yum HTTPD is for Linux. It's not for Ubuntu or Debian based Linux. Okay, so user data, as we said, it's gonna help us like boot, install any kind of software or do any kind of stuff we need before launching the instances. Guys, just give me 1 minute. Okay, guys, sorry. So we have our user data, and this is here you can see that it allows you to automate the setup of your instance, such as installing software, configuring settings, or running any initialization tasks. It's a cloud init process, so it begins when it first starts. So let's copy this bin bash script and let's use it on the user data. So this is our script. It's gonna give us Apache server installed. I want to allow HTTP, sorry, and HTTPS. We don't need HTTPS, it's just HTTP, that's fine. I don't want any kind of key pairs. I'm gonna remove it anyways. So yeah, I think that's it. So launch. Okay, so we talked about user data. Now we're gonna talk about instance type. So instance type are like basically very easy, but they're very like you need to know them at the end of the day. Okay, so let's check our launched instance. Actions. So if we go to actions, then we go to images, we can create a template from instance, but we're not gonna do that. It's still pending. Oh, I don't want to connect it, so let's Let me open the IP address. So let me open this instance. And let me open the address. It's not gonna open because it's on HTTP. So let me remove the S. Okay, it's still not loading for some reason. So let me open the DNS. Also S. Yeah, there we go. So here we can see that the Apache server is installed based on the script we have entered to give us a header. This is an HTML script if you know web development, sorry. So it's going to give us a header of type 1 that is called Apache server installed. So if we want to connect to this server, let me close this. So let's connect to this server and let's check if it's running. So let's do that. AMI is kind of interesting, but not gonna lie, I kind of like it. So we have checked that if we opened using the DNS name for it or the public DNS and we have changed the HTTP to HTTPS, it's gonna give us that Apache server is installed. So it's really installed. Let's check that out. So let's say sudo system ctl status httpd. Here you can see that we have an Apache HTTP server that is running and it's active and it is enabled on boot. Here we can see that it's truly installed, that the header that it gave us, the echo of the header, is based on an Apache server that is running and it's active. Okay, so now I want to take an image out of this instance. So let me go to the instance state and let me stop this instance, not terminate, just stop. So successfully stopping this instance. Again, not terminate, guys. You need to stop it. If you terminate, it's gonna be gone. So after it's stopping, it's gonna give me that it has stopped. So if we stopped an instance, it's not gonna calculate the cost on us. It's gonna stop working. So why should it be? Let's give it a moment so it can stop. So stopping. I don't have any kind of patience. I keep refreshing it. And then some people just like, please stop doing that. That's fine. Okay. So here we can go to images and we can create a template from instance. And we're going to create, call this template Apache server. Description, scaling guidance. No. This EC2 contains Apache server. Okay, so let's see it include. Don't include in launch template. No, we don't want anything to be included. Instance type. No, actually, I do want it to include in this. I want it to launch. Sorry. So let me include it in the instance type. My dude, why is it not clicking? Okay, so I want T2 macro, which is the free tier eligible. Okay, I don't want anything included. I want what is our instance, so I don't remember what kind of instance we use. What is, let me open another console, so AWS console. And let me see what kind of subnet is it in. So do I really have to log in? That's really, yeah. I'm gonna check what kind of subnet I used. Go to EC2. Go to our instance that we have stopped. So I want instances not running. Okay. So it's subnet. So let me copy this and enter it right here. Okay. And let's go to security group and copy security. We're gonna talk about security groups like in depth, and we're gonna talk about subnets also. So we want this security group, which is launch wizard 40. Okay, advanced details. We can also insert the script we have entered. So let's do that. Let's insert it right here. So create launch template. Create launch template. Sorry. Crash. Okay. So now we can like turn it on. I don't want to. So let's what's wrong with me? So let's launch another template or another instance from the template we have used. So let's go to launch instances. Let's call it my web server 2. And let's go to the AMI that we have created. So let's check it out. So recents. I think my my device is a bit slow. So let's refresh. Maybe it's gonna give us the AMI. Again, my web server 2. And browse more AMIs. It should go under my AMI. But apparently we have to like refresh the page again. That's fine. Let me go by instances. I'm gonna check if it have went to the template. So let's go to AMIs. Why is there no AMI? I have did an AMI, so let me refresh that. And start instance. Okay, guys, you have seen that we have initiated the AMI, but it kind of disappeared. So let's check why it had disappeared. So actions. That's weird. Okay, we kind of have public images owned by me. No AMIs in this region. Okay, so basically it is gone. It was weird. Volume key pairs, no. I want instances. So this should have an AMI of its own. I'm kind of weirded out by this, but that's fine. I'm gonna redo this again at the end of the lecture so we don't waste any kind of time. Okay, so instance types, we're gonna talk about, I think 5. Yes, it's 5 instance types. And then we're gonna talk a little bit about security, and then we're gonna talk about IP addresses. Then we're gonna give a 10-minute break. So let's do that. And let's go over the instance type. So we have basically 5. And the first one is general purpose, which we see that the T2 micro and M class are general purpose. These are workloads that need a balance of compute, of memory, of networking, and the use cases is for web server, test and development environment. So as you can see here, the instance we have is a T2 micro, which is, let me launch an instance again, and let's see the classes that we're talking about. So we have talked about AMIs and user data down here. And now we're going to talk about instance type. So as you can see here, if we click this arrow down, we can see T2 micro. And if we went like down, we can see that there is a lot of, here you can see that we have like a lot of instances. Some are available, some are not. And everyone is based on its use case. So if we click compare instance type, we're gonna see that there is a difference between memory, storage type, and all the stuff. So basically, this one has a storage of 1,680. So everything has its use case. So the general purpose one, which is, by the way, guys, you don't have to memorize the classes. I just put them here for reference. So if we want to use it for test and development environments, normal web server, we can use the general purpose. Now let's take it up a notch and let's check compute optimized. So anything with C is compute optimized. So C compute optimized. This is more suitable for, here we have said it needs a balance between the compute memory and networking. So this is more on the compute side. So we need more compute. We need more high performance processors. And these are for high performance web server, batch processing, and gaming servers. So basically, you know that gaming servers needs GPUs. So they need more processing power. So let's see here. We can see the difference between a T2 micro. So let's take a T2 micro right here. So the memory here is 1, and the vCPUs or virtual CPUs is 1. If we went down to a C, we can see that we can have up to 32 processors, up to 16 gigabytes of memory, and up to 640 gigabytes of storage. And we can see here that we have SSD cards. I think there's also a GPU processors, but let me check it out. That's fine. Okay. So this is more for a gaming server, for a high performance server, for batch processing. If you're in data analytics, if you're into um, stuff that requires data analysis, batch processing is for you. Okay. So let's now lower the compute, and we're needing a more memory stuff. So let's say memory optimized. So it's kind of like if we check it down here and we like draw it a little bit. So general optimize is we have memories, CPU processors, and storage all in one line. Okay, so this is general. So G. Let me write here we said memory, and this is P for processors, and then S for storage. Okay. By the way, M is for RAM is different than storage, like SSD and HDDs. So let's go now to compute. So compute, it needs more processor and the same memory and storage type. And let's take memory optimized. So basically memory optimized is we need more memory power and basically processors and storage to be the same. Okay, so here we can see it is designed for fast performance workload. So we need something fast that is large data sets in memory. So we're talking about memory right here. So RUX, which is the RAM. And I memorized it when I said R, it's for RAM. So here we can say we need it for high performance databases, real-time data analysis, and in-memory caches. So there is also in-memory databases that we're going to talk about later on. We have storage optimized, which is like, if you want to take a look at storage optimized, and I don't have any kind of colors, so let me use this. So storage optimized, I'm sorry, bad color. So storage optimized, we need more storage, same CPUs and same memory. So this is for NoSQL database. Memory is different than storage. Do you know the difference between memory and storage, guys? That's a weird question. I think most people don't know the difference between a memory and storage. Can anyone like tell me what the difference they think? Like, give me anything you think of. What's the difference between memory and storage? Without using ChatGPT, please, guys. Memory is RAM. Mm, correct. And storage is HDD. Storage, it's HDD or SSD. Okay. So memory helps us in the throughput in the input-output processes. So we can use it for in-memory caches because it's fast. You see here, it's fast and high performance databases, so it can retrieve the data in its SSD space to yes. Thank you, Patel. Thank you. That's good. So basically, storage, we need it for a NoSQL database, data warehousing, and distributed file systems. So as we said, these are in need of a lot of space, a lot of storage. As you can see here, it requires a high sequential read and write access to large database on local systems. So the difference is this is fast performance, so high performance database, real-time analysis. So the time from the RAM, like RAM is between CPU and memory, so RAM is much faster than basic storage. And these NoSQL database and data warehousing needs a lot of space to, like, NoSQL database stores everything, like stores social media, stores all the likes, all the comments. So if a NoSQL database can store this much, so basically it needs a lot of stuff. Also, data warehousing stores a lot of data. We're gonna talk about it in the database lecture. Okay, so accelerated computing, these are the most expensive. They use hardware accelerators or co-processors, and they perform functions like for scientific purposes. Like here you can see that it's called scientific computing, machine learning, and graphic processing. So these need more support. So we have here co-processors, we have hardware accelerators that make stuff go faster. So yeah. So I have a table right here. If we clicked on this link, so let's check out this links. By the way, Amazon documentation or Amazon Docs have a lot of knowledge that you can see here. So here we can see the general purpose, the compute optimized, high performance, no, not high performance, accelerated computing. So let's check DL1. So let's have a look. So DL1. Okay, here we can see DL1. So as you can see, when you choose DL1, you're gonna have for the 4,000 gigabytes, which is approximately 4 terabytes of storage. And here we can see that we're having huge memory, approximately up to 800, up to 100 CPUs. So that's a lot. That's like a lot. So can you imagine having a PC or a gaming PC like this? This would be heaven, not gonna lie. I started crying. I was like imagining me having an accelerated computing for a gaming computer. But that's fine. Okay, so here we have it on a brief table. So we have general purpose, compute optimized, memory optimized, and storage optimized, and accelerated computing. I have put them in a table for you to revise. So take a moment, read it, and then we're gonna continue our lecture. So take a moment and read it. Okay. So let me go back to EC2. I don't want to launch anything. So let me close this also. Let me check if my AMI is still not download. That's fine. Let's also give a brief introduction about security groups, key pairs, VPC, and subnets. So we have talked about key pairs. We have talked about subnets in previous lectures, and I have shown you how to SSH into EC2 instance. So let me do this again to you. I'll leave all the hands-on labs at the end of the lecture. I think it's better. So a security group, I don't like reading this. So let's write it down. We have, let me like remove all these. Okay. Okay. So let me put a barrier and we can start the comparison. So here we have something called a security group. And here we have something called NACL, or Network Access Control List. So what is the difference between these two? First things first, scope. So security group, so if we said scope, security group was on the instance level. And this is on AZ, let's say VPC level, so much bigger, sorry. So this is the first comparison. So security group, as we can see here, sorry, I don't like the line, so let me redo this again, much better. It's not much better, but so here we can see that the scope is an instance level. So the security group is our hotel doorman, and our network access control list is our passport officer. What? What am I writing? What does the doorman and the passport officer have to do with these stuff? Okay, so that's weird. Okay, so let's say we have a doorman right here. So let me draw, and this is our doorman. So every time you want to leave the, here's the door. Sorry, here's the door. So every time I want to leave or I want to enter this hotel, the doorman will ask me. So this is gonna ask me, where are you going? I show him that I have an hotel access. So so this is when I'm entering. He asks. I I hate this. I'm gonna write it. So doorman asks when I enter. Okay. So here we have the doorman ask, where are you going? Like, are you going to this hotel? Do you have any kind of access? Yes, I do. So when I try to leave, so let me give this a leave sign and whatever color this is. Okay. So when I try to leave, the doorman doesn't ask me where I'm going because he saw me entering. Like he saw me entering right here. I have an access card. So when I leave, he doesn't ask me where I'm going. So basically, this is called a stateful action. So stateful action. 1L, sorry. So a stateful action basically means that it writes down the condition, it writes down who enters, like a doorman asks when you're entering, not when you're exiting. So he asks only when you're entering, not when you're leaving. Not like the passport officer. So if we have a passport officer, why is the Z like this? What does this do? Okay, I want a circle. Give me a circle. Give me a good circle. Oh yeah, it did give me a good circle actually. But my circle is not fixed enough. And this is our hotel passport and I'm leaving. So I'm going into the airplane. بدخل في الطيارة. Airplane. And here's our passport man. Passport officer, not man. So if I'm entering the passport or leaving, he's gonna ask me where I'm going. So that's basically true. So if I'm leaving or if I'm coming in, he's gonna ask me where I'm going. Of course, because he's a passport man, I have to show him my passport if I'm going in or if I'm going out. So this is called a stateless action. So stateless action. So it doesn't keep the state of the machine or the traffic that is coming into this machine or not. So security group the instance, the scope is instance level, and network access control list is AWS VPC level. And this is stateful, like the hotel doorman, and this is passport officer. So stateless action doesn't keep track of the traffic that's coming in or out. So the default behavior for a security group, it denies all inbound traffic and allows all outbound traffic. So basically, if we have an EC2 instance, let me draw this. So if I have a small EC2 instance, then I have a security group, which is bigger. So let me do this as a security group here. So it stays here that's gonna deny all inbound traffic. So anything that comes in is denied, as you see here in red. So everything that comes in is denied, and everything that goes out is accepted. It's accepted. So let me do this accepted. So anything that in is denied, and anything that's out is accepted. This default behavior, this comes a lot in exam. It came on my exam, so please be careful. It denies all inbound traffic by default and allows all outbound traffic by default. And supports only allow rules. So everything is denied, as you can see here, and everything out is approved, and it only supports allow rule. Not like here. So here you can allow or deny. So allow or deny. And this only it allows. Okay. So key pairs, we have shown you that we have two kinds of key pair. We have a public key pair, which is our username, and a private key pair, which is our password. So stored by AWS and associated with your EC2 instance, and this is kept by you and only you, and this is how to secure your instance. So if we went to instances, and let's go to network security, and let's go to key pair, and let's create a key pair. So let's do that. So create key pair, an RSA key pair, let's call it my key one. That's it. We have RSA, PPK for OpenSSH, we can use .pm. For PuTTY, we can use PPK. I don't really care about this much. So let me open this key pair using, let me download it first on my PC. And I'm gonna show you what text it shows me when I open it. So I'm gonna download this right here and open it in Notepad. Here we go, Notepad. So let me copy and paste it here on Grammarly and paste. Okay. So here we can see that we have a public line, which is 6 lines, and we have a private line, which is 14 lines. It's all encrypted. We can't see anything. So these private lines are on our machine. So here we can see, and this is kept by AWS, which is the public line. And close this. Yeah. So here we have a public key pair and a private key pair, as we can see here from the private lines, public lines. As we said here, public is our username, it's kept by AWS, and private is our password and it's stored and kept by us. So VPCs and subnets, we have talked about them briefly in the networking session. So basically, let me select everything and just delete everything and all this. So basically, a subnet, a VPC is apart from a cloud. So VPC is apart from the cloud. So if you want to like draw it even more, so we can see that, let's use a highlighter. So this is AWS. And this is your VPC. So let's put this inside. And then we can even make it much smaller by subdividing our VPC into subnets. So this is subnets. Okay, so basically we can put instances on the subnet level. And this is where our security groups go. And we can have VPCs. So let's go here. So allows you to launch AWS resources into a virtual network, and here you segment your VPC into like a lot of parts. So this this drawing like really talks about the slide. Okay, so we're gonna talk very fast about Elastic IPs and public and private IPs. Then we're gonna have our break. So we can see here that IP addresses when we were launching our instance. So let's go to our instance. Have both private and public IP addresses. So let's go to our instance that we have launched earlier. Here we can see that we have a public IPv4 and a private IPv4. So basically, if we have a database on this instance, of course, we don't want it to be routable through the internet. We want it only routable through certain stuff. So you need to understand, why do we need to use our private IP address and why do we need to use our public IP address? So guys, if we have a database, should it be private or public? And if we have a server, should it be private or public? So this question is for you guys. If we have a database, should it be private or public? If we have a server that serves people, should it be private or public? So what do you think, guys? I'll give you a minute to think about it. You can write on the chat if you want. Okay, so basically, if we have a database instance that contains our data, contains our stuff, it should be private. So it should be private. And if we have a server that is serving other people, so it should be public. Okay. So this is the difference between them. So this is not routable over the internet, and it's used for communication in the same VPC. So here we can see it's in the same VPC. This is routable over the internet, and it allows EC2 instance to communicate over the instances. So as we can see here, if we're using the public IPv4, let me remove the S. So here we can see that Apache server is installed and it's connecting, but it's not secure. So let me go to the security group and remove the, so let me go to security group and let me remove the, as we can see here, we have allowed HTTP and HTTPS. So let me remove these. So let me remove HTTP and HTTPS. And now let's refresh. It's not gonna load because we have removed the HTTP rule in our security group. So here we can see that we can't access it. So all inbound rules are denied by default, as we can see here that after we have removed the HTTP rule, it is denied. So here you can see it's still loading. Then it's gonna like give up and tell me that I'm sorry, I can't reach to this server. That's fine. Okay, so this is the difference between a public and a private IP address. You can see here it's still loading. It's not gonna remove the load. We have something that's called an Elastic IP. So do you remember, guys, when we have entered the IP of Google, which is 8888, this is a static IP address for Google. So if you write 8888 is gonna route us always to DNS Google. Here you can see that the site cannot be reached. That's fine, we know that, thank you. And having like DNS name, so let me 2333 resolve. So yeah, every time I put 8888, it's gonna give me to Google every time. So here you can see DNS Google. So let me go back to threes. I don't remember what it gave me, so resolve. Here you can see external master Amazon root Amazon. Okay. So Elastic IP gives us the ability to have a static IP address. So as you can see here, that 8s are for DNS. So Elastic IPs, you actually can have your own private IP address, public IP address, and it's static. You can reassociate it with another IP address. So if we have, let me remove this. Here, if we have Elastic IP and we have two EC2 instance, and we can associate to this one, but let's say this EC2 instance is out of service, we can remove it and reassociate it to this one. Also, its cost, they charge for it. So in a nutshell, this is the features. So it's static, and you're gonna pay for it. So it's gonna cost you. So use cases, either use it for failover scenarios. As you can see here, this is a failover scenario. So this instance was failing and we removed it and associated to another instance. Or if you want a consistent addressing like the 888 right here. So here's a DNS Google, which is using 8888. Okay. So guys, we're gonna have a 10-minute break. So let's see. Okay. So guys, we're gonna come back at my timing. We're gonna come back at 6:15. So please make sure to come back at 6:15 so we can continue the rest of our lecture.